All right, gang, it is now time to crack open our 802.11 frame, see what's inside, and really get a feel for the type of communication that's occurring with 802.11 frames. Remember, we're not dealing with what happens once it gets past the access point, but everything up to that point is framed using a layer 2 header based upon the 802.11 specification. It's not Ethernet, all right? It's its own unique animal. Let's take a look. We can see that it begins with what's called frame control. So what version of 802.11 are we using is a key question here. We also see the important question, are we going to or from the distribution system, which basically means the access point. Then some questions about power management, retrying, the order frames, things like that. But the next thing I want to do is after these first 2 bytes, we get to the duration. How long should other devices wait while this truck moves on through the wireless network? Remember, duration is extremely important to adjusting the network allocation vectors used by everyone else as they are waiting for their time to speak on the network. Then we get to the address, right? First address is always going to be the receiving address, so who is this intended for? But then things get a little tricky. We have the receiving address, we have the transmitting address, but then we have other questions like address 3 and address 4. Got a little sequence control just to manage a sequence of packets, frames I should say, that are designed to work together. Then we get to the frame body. The frame body is actually where we get to the IP header and the TCP header and the application header, right? Whether it's secure shell or HTTPS, whatever it might be. That's all tucked in there. And all of that in any particular frame will be added up and mathematically computed to derive what's called a frame check sequence. Essentially, if you added up all the ones and zeros, you'd get a number. What is that number? Let's say it was 112. You add the number 112 to the end of the frame. Then you send the frame. When the frame gets received, the recipient also adds up all the values. If they get 112, they know it's good. If they get 110, whoops, we slipped a bit somewhere in between the source and the destination. Therefore, it will drop that frame. It is no longer considered valid. Let's talk a little bit about those addresses. Gang, remember that with wireless, everything's got a MAC address. So between the client and the access point, there's shared MAC-to-MAC communication. Between an access point and another access point, there's shared MAC-to-MAC communication. But really, my MAC address is trying to communicate with this other MAC address. We're all on the same VLAN. It's still local to me. So I should be able to communicate with that MAC address over there of this client up here at the top. How does that occur? It occurs because we actually have 4 MAC addresses to keep track of within our frame to ensure that things get sent correctly. So we have not only the transmit and receive question, but more like almost like an IP address, we have the idea of source and destination, which may appear in these locations or something else may. Let's take a look down here at the bottom. Every time in the frame control we see to or from distribution system, remember that basically means, is there an access point? So I'm just going to add that icon here. So from an access point to an access point, here's our access points. Every time it's not enabled, that means we're essentially coming from an individual client. So here's all of our client configurations. So let's see what's going on with the address fields based upon the type of communication that it is. So let's say we had wireless ad hoc communications directly from client to client, like you see, for example, right here, this shared network space. Well, then we have always at the head of the frame is who's supposed to get it next. That's always the important thing. We read that first. Okay, so the recipient address is also the ultimate destination, right? That's the final MAC address we're trying to reach. We're transmitting from an address, which also happens to be the source address. And then the third address is the BSS ID, and again, that's essentially the network ID that we're communicating with. How about we're more like normal? We're using an infrastructure network. Well, when I try and communicate with the access point, or the access point tries to communicate with me, we're going to have to frame things a little bit differently. So again, in this case, we know we're coming from a distribution system, an access point, to a client. So the receiving address will be the address of the client. That's also the ultimate destination. The transmitting address will be listed as address 2, which will be the value of the BSS ID. The source address, though, might be this guy out here, right? So this is a message coming this way. So therefore, the transmission is actually the source address listed over here as address 3. That's the MAC address of the actual other device that's on the network, maybe on the Ethernet network. How about when it goes the other way? Well, in this case, we're trying to communicate to our access point. So remember, all communications, remember, we got to line them up this way. All right, so we're coming from a client to an access point. So the receiving address is the MAC address of the access point that we're trying to talk to, which is identified by the BSS ID. The transmitting address is the source address, right, because we're coming from the client over here. And then we're trying to get to someplace else, right, some other MAC address. So we're actually trying to get out to this device that's way out here. So that's the MAC address that will be listed here in address 3. So for none of these situations do we need address 4. Why would I need address 4? Well, sometimes we have an access point to access point communication, and that's what we see here in this area because I've got maybe a repeater. I connect to a repeater device. The repeater then connects to the main access point, which is actually connected to the distribution system, the switch, and the rest of the network. So who should receive it? Well, the next access point in line. Where is it coming from? Well, from this access point right here. Where's it going to? That's this destination address out there. Address 4, where is it originally coming from? Oh, from this access point right here. So again, in that case, all 4 address fields need to be used because we're at an intermediate link in this journey.